The first two law of motion tells us how an applied force changes the motion and provide us with a method of determining the force. The first law and the second law both tells us about the action of force when it changes the motion of an object, and it also the second law tells us how to find out the how to determine the force, how to find out the force, how to measure the force, the applied force. But the third law of motion states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. This is an action and reaction of a forces we'll find in the third law of motion. There is action and the reaction of forces. For example, suppose if I throw a ball on the wall, that is the action, and the ball bounces, that is the reaction. Okay, as much as I will apply the force, the ball will bounce with that intensity. If I throw a ball with great applied force, then the ball will bounce with that much of intensity. Here the reaction and actions both are same, and they are opposite in direction. Their magnitude are same, but they are opposite in direction. They are not in the same direction. And second thing, they are acting on two objects. They are not acting on only one object. The ball is acting on the wall, and the wall is acting on the ball. The action of the ball and the reaction of the ball, reaction of the wall on the ball, makes the ball bounce. So you can alternatively, third law of motion can also be defined as to every action there is an equal and opposite reaction. To every action there is equal and opposite reaction. However, it must be remembered that the action and the reaction always act on two different objects. They don't act on only one object, but they act on two different objects. Just now I explained that the action, the ball is acting on the wall and the wall is acting on the ball. So the objects are here two different. The action is on the wall and the reaction is on the ball. It is important to note that even though the action and reaction forces are always equal in magnitude, these forces may not produce acceleration of equal magnitudes. This is important. There may be the forces, the action and reactions are equal in magnitude. What is magnitude? It is a number like 5 Newton, 10 Newton. So this 5 Newton, 10 Newtons is known as magnitude. So the important thing about here is that even if the action and reaction forces are always equal in magnitude, these forces may not produce acceleration of equal magnitude. This is because each force acts on a different object that may have a different mass. That is why the acceleration produced is not the same, even though the forces are same. The actions and reactions are same. For example, the ball doesn't make the wall move back, but the wall make the ball bounce, because the mass of the wall is very much as compared to the mass of the ball. So the acceleration produced on the wall by the ball is negligible, but the acceleration produced by the wall on the ball is more. It's okay. So in the same way, when a gun is fired, it exerts a forward force on the bullet. The gun, the chemicals inside the barrel of the gun, it explodes and makes the bullet go fast. The bullet exerts an equal and opposite reaction force on the gun. This results in the recoil of the gun, means the gun moves in the backward direction. The bullet goes in the forward direction and the gun moves in the backward direction, and that is known as the recoiling of gun. Since the gun has a much greater mass than the bullet, the acceleration of the gun is much less. The acceleration of the gun is much less than the acceleration of the bullet. The acceleration produced by the gun on the bullet is very much, but the acceleration produced by the bullet on the gun is less, even though here the action and the reactions are same. It is here, even though the acceleration is not the same. The third law of motion can also be so this is a good illustration of the third law of motion.